I'm Jake Bruton, and today on The Build Show, we're going to have a simple conversation about what is wool insulation. Let's do it now. Okay, so I am joined by Josh from Havelock Wool, and the reason that we're going to have a conversation that doesn't really involve the installation process is because I've made videos in the past, we've talked online in the past about different types of insulation, the pros, the cons, the carbon footprint, the insulation value per inch, and those are mostly insulations that you're familiar with, the spray foam, the fluffy fiberglass or cellulose or mineral wool insulation, foam boards, things like that. But I don't think that very many people are familiar with wool insulation. And as you guys like to joke around, it's not mineral wool. It is sheep's wool.
Yeah.
And so you get people calling all the time going, I'm looking for mineral wool, but they just haven't paid attention.
Yeah, well, in the industry, wool is used to describe
Yep.
the fiber of what we're trying to make here. But yeah, it's actually from a sheep.
Okay.
And it's the oldest insulation on the planet. So, in this country, we're starting to accept newer or alternative materials, whereas in the UK and Europe and the EU, it's been used commercially for decades, if not centuries. The farmer has to shear a sheep and stuffs it in the wall back in the old days, and now with modern machinery and cleaning and processing, we're able to make an actual grade product that is suitable for homes and commercial use with a high R value and loves to be in there managing moisture. It's an interesting fiber.
Okay, so let's start. Where do you guys get wool insulation from?
Yeah. Well, currently we buy all of our raw wool or raw material from New Zealand. There's many reasons behind it. There's a trade, of course, behind the trading wool, so you can buy it easily on the market. It comes cleaned, it comes compressed to maximum density in 20-foot containers. So to make a professional grade product, we have to have high quality material to start with. And typically, wool, the sheep are partying all day long, rolling around in the hay and the dirt and the dung, and you got to pull all that stuff off to have a nice clean material. And so New Zealand is just a great choice for that. Domestic wool might happen someday, but there's really no trade here domestically to clean it and to transport it and in the quantities we need.
So what Josh is saying is there is an industry that already exists prior to you guys being around in New Zealand where they have sheep that are, and this is not, we should clarify, this is not sheep's wool that would be your long underwear or socks or anything like that eventually.
Yeah, typical merino is a fine hair you want to reduce the scales so it doesn't rub on your skin, right? But we're going
to make it more comfy.
To make it more comfortable, correct. But since we're not wearing this, a coarse wool is preferred as under a microscope it has a lot more scales, and those scales trap air naturally, higher R value.
And so these sheep are, you were telling me these are meat sheep.
Yeah.
These are sheep that are going to get eaten after they're sheared a few times and grown to a point where they're going to be harvested.
Yeah.
And this is kind of like a byproduct of that.
It's a dual-purpose breed. It's called the Romney breed, and its original purpose is for meat. So we're grabbing the wool off of that because the farmer has to shear them every 5 months or so, and typically that wool isn't used for much. So we're helping to keep those sheep where they are. The fear is that perhaps you don't buy the wool, there's no meat market left, and then the cows move in. So we're trying to keep that pastoral land of New Zealand going.
And so they're sheared, roughly twice a year. Mm-hmm. The loose fill stuff ships in 25-pound bags, is that correct?
Yeah. So we sell the loose fill blow-in. It sells in 25-pound packs, and then there's a coverage calculator so you can figure out your cubic needs based off square footage or R value. But it shoots in like almost anything else. You put it into the blower, and then it goes into the wall.
And so at that 25-pound amount, that's 1.5 sheep per year.
Yeah,
making
yeah.
that,
I think
or something
you're,
like that.
yeah,
1 and a
I think
quarter.
of the Romneys, you're pulling maybe 10 pounds, 10, 12, maybe 15 pounds a shear off them.
Okay.
Yeah, so they're 2.5, shearings full or sheep. Yeah.
So you can picture that one sheep as the one that insulated that one stud
Yeah, well, when
bay
you
or
start to
whatever.
add it up, you need a lot of sheep.
Yeah.
And a significant part of New Zealand's gross domestic product is the export of wool. They have a lot of sheep. We don't.
Okay, so this stuff is sheared off the animal. It is transported semi-locally inside of New Zealand to facilities that already exist that process. And talk me through the process. Are they dumping a bunch of chemicals in this stuff to make it clean?
Yeah, well, there's two ways of cleaning wool. I mean, first of all, wool has a lot of grease and lanolin and skin secretions besides the vegetable matter, the VM, dung, dirt, hay, and that's got to be removed. Typically, how you cut grease is with harsh chemicals or hot water and agitation. And so we choose the hot water and agitation. We use something to the equivalent of Dawn dish soap, right, without the fragrance, without the dye. And it does a great job, and it's just multiple processes called scouring to get the wool very clean and to our specifications.
And so how many wash cycles is it going through?
They go through bins, and I think it goes through 3 different bins before it's to our specification.
So basically, we're from animal to your specification, and we are Dawn. We're dish soap the way that they would treat baby ducks that got grease on them.
It's that's full circle, just like that. Yeah.
And then is there anything else that's done to it after that point to get rid of insects or anything like that?
Yep. And then, so in New Zealand also, we treat with 8% boric acid.
Okay.
And so boric acid is used widely in the insulation industry, cellulose, cotton, as a flame retardant. Naturally, wool won't ignite, so it just smolders. But in this country, we have a little bit higher standards for insulation, so we add a little bit of boric to get that Class A of ASTM E84, which we think is a very big deal.
Yeah.
And boric is also very effective as a long-term deterrent for bugs and moths. And so that's a big deal too.
So we don't have moth issues here necessarily.
No.
Okay, so we're clean, we're treated for that Class A fire rating, and we're deterring insects and moths.
Bugs and moths, absolutely.
That Class A fire rating is something that is common across basically every insulation on the market in the United States. That ASTM, is it E84?
E84, yeah,
is
the test.
a standard, and it's my understanding, because I looked up the test.
Yeah.
It's not a pass-fail. You get a grade based on how you guys do, and you guys are at the top of what it allows. It's a Class A fire rating.
Yep,
right?
Exactly.
Okay.
And then within that Class A, you have the specifics, the numbers of how you pass, and we're still quite high because it doesn't combust very easily.
Yeah.
You put a flame on it, it smolders, and eventually goes out.
And so then that product is shipped in a container from New Zealand to the West Coast and then to you guys. When they pack it in a container, what numbers are we looking at?
Yeah, so then it's an interesting process. They compress with a 200-ton press, maximum density, into 800, 900-pound bales. It's really interesting to see a rock-solid brick of nice fluffy wool just at maximum density. And in a 20-foot container, we stuff about 44 of those in there.
So then math-wise, a house this size that's 2,600 square feet, we got 40 bales.
Yep, we put 40 bags in, 25 pounds apiece. Yeah,
so we're looking at 30 or 40 houses in one container.
Yep.
So there's people hear the same as I did.
Yeah.
What's coming all the way from New Zealand? That seems ridiculous.
Yeah.
And then once you hear the numbers and you go, okay, well, everything is being shipped from somewhere.
Yep.
We're making an impact no matter what we're using.
Yeah.
We can choose to use things that have a better, installation value, a better health aspect, or we can choose things based just on what carbon footprint it is.
Yeah.
And I don't think that we have an argument that it's poor for the environment from a carbon footprint.
Container shipping is wildly more efficient than truck shipping.
Because there's 1,000 containers on that one boat
4,000,
that are all going at the same time. So that was one that I wanted to make sure that we talked
And then from
about.
the port of Oakland is 200 miles to our factory in Reno, and we haul that thing up and do a couple a month and just keep the wool moving through the facility.
Okay, so then your facility, you get a enormous bale
Yep.
that is rock solid.
Yeah.
And then what happens?
Yeah, so what happens there is actually kind of interesting when we do walkthroughs with customers or employees. But basically, we have a metal cage that goes on top of the bale, and then face shield, leathers, grinder, and you cut the metal straps and they explode. It's like a shotgun. I don't know, there's 16 straps on it, and you get to the end and it just explodes. If that metal cage isn't there, it becomes dangerous quickly. It'll whip right through your leathers. So that we open the bales up, they go onto what's called a bale breaker, and basically the whole process for us is we're opening the fiber. So you sit here and you open the fiber as much as you can to create more air, and then we start to orient the fiber in different directions for the different products we make. And then the bat product is kind of interesting to us in that we don't use glue. Typically when you make insulation, you have to glue your fibers apart from each other to create airspace. So instead of gluing, we use needles. We take about 1,000 needles on a big board, and they're 4 inches long, and they have barbs on them, and the needles go through and sew the fiber together with its own fiber. And that's how we create a bat.
Kind of like the same way that they get wool to hold together to
Yeah.
begin with. It's all about how it gets twisted together to make something.
Yeah.
And we don't make sweaters with glue.
No, what's interesting is that the machines we use were made 70 to 100 years ago. They don't exist anymore. They're dinosaurs. And we take them and we gather them up because there's fewer and fewer of them around, and we have a junkyard of spare parts, and you have some great fabrication folks that work for us that are able to fix anything with nothing. And you just keep these machines running. You put electric motors on them, so we can control them on a computer and have a little bit of ability to adjust and tune the machines to get the product that you're trying to make.
Okay, so if you follow Havelock on Instagram, one of the things that you will immediately notice is the van life aspect.
Yeah.
And when we were having a conversation about it yesterday, we were joking about Instagram influencers and people living in their van and Walmart parking lots and things like that.
Yeah.
But there were two really interesting things that came up. Number one, the idea that it's a metal box that then you're going to insulate and cause condensation issues and vapor drive inside there. And what insulation could you put in there that would work as easily as something that's not bothered by water?
It's a great testing ground for what we're trying to communicate, and that is, we make healthy insulation for a living, for a reason, and when you put it behind a wall, we tend to forget what's there. And some would argue there's a wall so you can't see what is behind it typically. Yeah, but when you put it in a van, you're sleeping in close quarters. You're breathing that airspace. And it becomes real apparent that I'm sleeping next to something that I don't know its composition, whether it's chemicals or just synthetic materials. And so when you're living in a van too, there's a lot of condensation issues. It's a metal box, and that obviously has no outward drying potential. So when there is wetting, when there are condensation overloading, wool just does a great job managing. It absorbs and it releases it. When it absorbs water, which is typically a bad thing for insulation, it doesn't really absorb it. Like, you can't wring it out like a sponge. It's called chemi-absorption, and it goes into the fiber, and they remove a water molecule, and it's not water anymore. And then it releases that back when the relative humidity drops and balances out the space, and that has a cooling effect. So it modulates moisture and modulates heat, which is kind of interesting.
And completely unique to the way that wool works as an insulation. I mean, it's why we use it for clothing.
Yep.
So I thought that was really impressive. That that idea of how it works in such a strange environment that we would be asking some other insulation to work and not do the same thing. It would work differently.
Truth be told, we like to ski, and skiing's in a cold climate, and you have a family, you have a van, and what are you going to do with your van? You have to insulate it. And so the light bulb, goes off in Andrew's head, and we're insulating it with wool, obviously, and we're going to test it, and we're going to go to the Jackson Hole parking lot and sleep in it, and it's 65 inside and it's negative outside, and you're just hands above the head, just watching TV and waiting for the snow to fall. But that was kind of the proving ground for how this stuff works. And we love the van community and everything about it because we want to get out there and have fun. It's just too short to sit there and not go anywhere. You have to go have fun, and the van guys do.
And when's the last time you heard somebody in the insulation industry say, go have fun?
Yeah.
That just doesn't happen.
Well, we chuckle every day because we talk to people all over the country, answer questions. We want to be as helpful as possible. A large role of what we do is education. We have to tell people what this stuff is because it's different. And so it is so fun to just talk to people and hear what they're doing, the travels and the experience, and you have great conversations about insulation. And I just don't know who does that. Like, why, people come from all over the country to pick up their wool because they're driving around, and you just meet wonderful people. They're doing the coolest things, and it's all because of insulation. Yeah.
So the other two questions that I've had since I started commenting about this at all, number one is the allergy standpoint. And I think that people are misled that if you've had a sweater that you thought you were allergic to in the past, it's probably because it wasn't merino wool. It was a scratchy, itchy fiber, and you were bothered by the itchiness of it, not the actual chemical makeup and having a skin allergy. You were having if you rub sandpaper on your skin, it'll look like you have some sort of allergy to sandpaper, but it's the fact that it's abrading your skin. Is that fair to say it like that?
Yeah, absolutely. Allergies, everyone's allergic to everything at this point, as we just introduce more chemicals and toxins into our lifestyles. Typically when people are allergic, they already know it. And it's because how it rubs their skin. But wool is processed very differently. We talked about New Zealand, but domestically, it's processed differently. There may be extra lanolin or skin secretions, or it's
or synthetic fibers that are
synthetic fibers. But people are rarely allergic to wool, but it does happen once in a while.
But people have, like you said, people are allergic to all sorts of things. In our house, it's one more thing that goes into the decision-making process.
Wool's a known hypoallergen, so it tends to not generate an allergic response from folks. And then there's all these other benefits of the amino acids inside of the wool fiber that literally wrap themselves around VOCs. So now there's this whole science behind what we can absorb into a wool fiber and lock up permanently. So it's also an air purifier, which is really interesting.
And again, unique to wool.
It's kind of, there's so many wonderful things about this fiber. It's hard for a lot of our customers to understand, because if you didn't invent it in a petri dish, how can this be better? And having been on the planet for a very long time, it does a lot of things.
There's a reason we still keep sheep around.
Well, you don't see moldy cold sheep. They're
They're
having a blast, and it's raining and snowing, and they could care less, and they're warm.
So the last one that I know everybody wants to hear the answer to is, well, but how much is it compared to other products? Because insulation value, R value-wise, we're very close to the competitors for it in fiberglass and cellulose. Like R value per inch is not a dramatic change one way or the other. So you're not buying it for a higher R value, but what does it do to our budget in a normal circumstance?
Well, I think that I know that on a new build, your budget for insulation is typically 2% of the overall build. So folks want to spend more on perhaps countertops or furnishings inside the house, and it is more expensive. It's more expensive than fiberglass. I'd say it's more on par with the cost per square foot of spray foam. But as we all know, insulation cost varies drastically from coast to coast and where you buy it. When people start considering more about what they're surrounding themselves with, then the cost of a healthy material becomes much more clear.
Okay, I was actually hoping Josh would bring it back like that, because I think out of everything that we've talked about, the two conversation points that I'm going to have when selling this product to anybody are, what is the health benefit side? How does it affect your house from a healthy standpoint? And what does it cost? And I think that it just depends on which one of those things is going to be more important to my clients. Because when we talk about cost, The zip R that's behind this cost more than not using the zip R. The triple glazed windows cost more than using double glazed American manufactured windows. The 1.125" subfloor that we're standing on from Advantech costs more. Like, there are all these things that we've made a analysis of and made decisions to consciously spend more money. And it's not just because we want the clients to spend more money. So I think that everything has a push-pull, everything has a give and take, and we just have to be informed about what we're doing to make those decisions. And I don't think that the product's going to be right for every one of my jobs, but I definitely see that there's interest in my market for this with my clients, and that this is something that now we need to continue the conversation about.
And we try to make the point that you don't have to put it everywhere. Right? Plenty of folks insulate the entire home with just sheep's wool, but if you put it in strategic spots, that's better than nothing. You want more sound attenuation in the bathrooms, or in your living room, or your bedrooms where you're spending a lot of your time. You can make that space much more comfortable, clean air, nice and sound deadening, and modulate temperature and humidity.
Yeah, and that conversation applies to here. We're using it in the walls. The walls are inside of our envelope. Above our envelope, outside the envelope in the attic, we are using something that's more cost effective up there because it's outside of our air barrier, and it's not ever going to be something that gets inside the house. Yeah. So we consider that space outside, and we're not worried about anything air quality wise that's outside. When we come inside, we have greater concern as to what we're putting inside the house.
If you think about it, now more than ever, as we're pushing to build airtight, and building science is now a thing that lots of us understand and thrive to learn more about. As we build it more airtight, the materials we use are now getting more heavily scrutinized.
Yep.
If it has off-gas potential, is it clean? Do I want that airtight to be full of fumes and off-gassing, or I want it full of a natural product that I know its background? And that's now becoming more mainstream.
Okay. There you have it. We make an argument based off of different choices. This is one choice that we can make or not make. We'll have another video next week where we'll talk about the installation process and the couple different products that you guys offer. But I thought that this was a long enough primer video for people to understand what we're going to talk about next week. So I want to say thanks to Josh and thanks to Havelock for coming and helping us with this. I also want to say, if you're not subscribing to the Build Show Network's weekly newsletter, you should, because you'll get a weekly video update as to what Matt Reisinger, Wade Paquin, Steve Basic, and Brent Hull, I said that really fast, are putting out every week. Everybody's putting up new content. It's awesome content. I'm really happy to be involved, and I learn stuff from the website every week when I watch everybody else's videos. Don't forget to follow me on Instagram. Stay tuned next week where we show you how this stuff gets installed. Thanks for watching.